Hello, my name is Jackson Schuler, and I am the principal investigator for Project Vestia, and I'm also a lifelong proponent of Martian colonization. Ever since I was little, I've wanted to go to Mars, and for the past 7 years, I've been doing research into industry standards, where things are going. I can fairly confidently say that the future of interplanetary habitation is inflatable habitat modules. And these modules are made from a flexible fabric-like material that allows it to collapse inward during transit, taking up a lot less space, but upon reaching its destination is able to inflate back out. Now, recent demonstrations in zero-G environments, such as the beam module on board the International Space Station, have shown them to be a very viable option for long-term habitation. However, when applying them to terrestrial applications, there is one drawback, and that is the fact that there is no flat, solid surface for the astronauts to work in. By nature of design, habitat modules have to be cylindrical or pill-shaped to minimize the surface stress from the great pressure differences, and these rounded surfaces aren't conducive for astronauts' daily lives. Now, as I said, I've been studying this problem for several years, and the solution that seems to be most viable is to implement the techniques of origami to have multiple folding panels that fold up during transit, but are able to extend back out to provide a solid surface once deployed. Now, I've done some initial design work, and I've come up with a design that is able to expand to cover an area that is 4 meters by 8 meters, as demonstrated by this 3D printed test model. But during transit is able to fold up to take up much less space, folding into a 3-meter diameter area. And that 3 meters is important because obviously these systems have to be sent to the Martian surface. And so I put parameters in place to make sure that a single launch of the SpaceX Starship vehicle, which is kind of the up-and-coming mass Martian transport system, can carry 40 of these habitats to the Martian surface, which would provide over 10 times the habitable volume of the International Space Station. Now, that may be a bit much, so even scaling that back to provide a still large base would also leave plenty of room for cargo and initial supplies, so a single launch would provide the entire base structure as well as the initial setup stuff. Now, currently this project is in its early stages. My 2 faculty advisors and I are in the process of recruiting undergraduate team members and applying for funding, as well as continuing the design process to create a full-size test article. Now, that test article is going to be used to demonstrate the weight-bearing capabilities to kind of optimize the design, as well as to determine the potential collapsing and expanding procedures that would be used in the real world. This would be great insight into the feasibility of such a system, as well as to improve that system to eventually implement it and further the goal of making mankind an interplanetary species. Thank you so much for taking time to hear about my project.